Good afternoon, classmates. I hope you are having a wonderful summer so far. My name is Glenn Yeep, and today I'm going to show you our calories tracker. This project is designed by myself and my partner, Omar and Chesta. As you can tell from the project title, we designed a pretty cool program that can help individuals to reach their desired weight goal. Our program is aimed at individuals who wants to know their full caloric intake to achieve their desired weight goal set in mind. Often people are too busy with their lives and they forget to keep a track on what they eat and how much they eat. And when things get worse, losing/gaining weight is something people tend to, which is why our program serves as a tool to calculate the daily caloric/nutrient intake and the recommended daily caloric intake, which is based on the user's weight goal. So as we move on to the application overview, we take in some general information about the user as inputs, and we output the following stuff. All of our calculations are based on scientific formulas, which helps us with the credibility of our calculations. And if we move on to our application demo, and if we start this up, as the program runs, we're presented with this first scene. I'm just going to enter a name. Oops, looks like I entered an invalid name. Let me put in a correct one. There we go. So now we're presented with the general information that we need from the user. So we can choose between male and female. I'll choose male. Your age. I'll just put in reasonable inputs as for right now. And this part right here, it shows how much you want to lose or gain weekly. So let's say if I want to lose 0.25 weekly, and this is the activity level, so we see how much the individual exercises, and that helps us with our calculations. And this is the total amount you want to lose as a whole. So let's say we want to lose 4 for right now. So now I'll show you our error message class, where we have set ranges for valid inputs like age, height, and weight. A 9-year-old and an 80-year-old are advised not to lose weight, as it can cause more harm than good. And all the other inputs, or any inputs, will not accept any excessive large number or any abnormally small inputs because they're not reasonable and it's invalid. So for example, I'll show you. If we say that we're 100 years old, we'll say you're too old. Let's put this back. And it says, so let's say someone says they're 500 kilograms. It's not reasonable, which would show this error message. So let's put that back. And let's say someone says they're 300 centimeters. It'll also say error message. We also put an error message for the total amount they want to lose/gain. So it could be so they input a reasonable one. So let's say if someone says they want to lose 60 kilograms, we'll present them with this error message. So let's put that back to a reasonable one. So then if everything works out, checks out, we'll give the user some facts about their health. We'll give them the amount they need to lose, amount of calories they need to take in, and the amount of days it will take. So now we also take in the type of dietary the individual it is. We calculate the how much they eat, with all the calories, and we are giving them certain foods that they might have eaten the day of. So let's just choose a regular dietary. So now we're presented them with options for breakfast, and they can choose which one they have eaten. Let's say if they ate oatmeal. Lunch, there's 3 options, and fries. Let's say steak and rice for dinner. Then we ask them what type of exercise they have done for the day. Let's say if they have done running, boxing. There's all these different options. I'll just choose boxing, and how much they spend, how much time they spend on their exercise. So let's say we did it for 60 minutes. So now we present them with their net caloric intake for today, and if it's enough to for their recommended daily intake from their past inputs, and then we show them their daily macronutrient intakes, and then the recommended macronutrient based on their recommended daily intakes, which is a split between 30, 40, and 30. And I can show you the food options. These are the food options, and we set them to different um dietaries. So only certain dietaries can see certain foods, and that's pretty much all. We'll move on to the UML now. Thank you.
Right, so moving on to the UML diagram. We had quite a few classes, and so the diagram looks a little bulky and confusing at first, but I'll go through each class to explain its purpose. So the starting point of all JavaFX applications is the application class, which is extended by the main class. The purpose of the main class is to basically start the application and set the first scene. This is the only purpose. Now, before I move on to the core classes of our project, I'll just go over the controller classes that we have. So we had 7 different scenes, and we decided to have a different controller class for each scene. And so we have 7 different controller classes. The main purpose of the controller class is to basically switch to the next scene after doing some input validation and calculations. Another purpose of controller classes is to set the text of the labels on the next scene based on the input from the previous scenes, which you can see by the methods right here: set calorie labels, set macros labels. So we're basically setting the text of labels on next scene using the controllers. The controllers do not have a relationship with any classes. They're independent classes, and they're only used for switching and manipulating scenes. This is the purpose of the controllers. Now I move on to the person class. The person class has a lot of attributes and a lot of methods. And this is because the information that we're taking as input from the user is given to the person class to construct an instance of the person class. The attributes of the person class correspond to the information that we need in our program. For example, the BMI and the BMR values, they're used in intermediate calculations as well as they're outputted directly. And so the person class is responsible for calculating values of these two based on all of the other inputs that we take. And they're also stored as attributes in the person. So this is the purpose of the person class. Now the error message class. The error message class is basically used to return an error message which is unique to each case. Now, while taking input from the user, there's a lot of things that could go wrong. As Glenn explained in the first part of our presentation, we have ranges set for valid inputs. For example, a person who is younger than 9 years cannot lose weight, and a person who's older than 80 cannot lose weight, because these are unhealthy ages. And so if a person inputs an age that is above 80, they should get a different error message saying you're too old to lose weight, for example, and then a person who's below 9 years old should get a message saying you're too young to lose weight. So there's a lot of scenarios like this which needed a separate error message, and the error message class is basically responsible for producing those error messages based on different scenarios. Next up is the meal class. Our meal class is an abstract class, because you could not have a meal without specifying which type of meal it is. In our program, we give the user 3 different types of meals: breakfast, lunch, and dinner. And if you look at them, they're identical except for the fact that these meals are taken at different times of the day, and that's the only differentiating factor. And so they inherit the meal class because they're supposed to have all the same functions of the meal class. Each breakfast has a name and a calorie associated with it. We're basically giving the user 3 different breakfasts, lunches, and dinners, and so each breakfast has an associated calories with it, and which is stored in the when you construct an instance of the class breakfast, lunch, or dinner. So these classes are used to ease up our code and for further calculations. Now moving on to the food class. This is a really important class. This is also an abstract class. Now we're giving the user 3 different types of diets: regular, vegan, and vegetarian. Each of these diet types has its own class. Each class only has one method, which is the calculate calories method. The point of these three classes is to return total calories and the nutrients that are taken by the user. So if the user picks the regular diet type and he picks a regular breakfast or regular lunch and a regular dinner, we pass these parameters into this method and returns an integer array which contains the total calories and the nutrients associated with those with the food. So this is basically to get the nutrients from the food. We've created these three classes. Now, the food data class is another important class. The food data class basically contains all of the possible foods, all of the foods that we're giving the user to pick from. Now, all these foods are stored in a hash map. Why we use the hash map? I'll explain it in the next slide. But for a quick summary, we're using hash maps because we wanted to associate the food with its nutrients, which basically is what the hash map's doing right here, serving as a key value pair. Now, regular, vegetarian, and vegan, these three classes have a composition relationship with food data. This is because regular, vegan, and vegetarian, all three of these have an instance variable food nutrients, and the food nutrients is a hash map which contains a food item from the food data and the nutrients of that food item. So these three classes could not exist without the food data class. The food data class is basically storing all of our foods. Next up is the nutrients class. The nutrients class is basically responsible for holding all of the nutrients in the food and the total calories of the food. We construct this class when we need to store all of these inputs. All of the proteins, all of the carbs, and all of the fats, and the total calories. And then we have the getters and setter method as well for this. Next up, we have the exercise class. The exercise class, we basically use this because in one of the scenes, we're asking the user if they've exercised in their day. We're asking a specific exercise. For example, we give them the options of leisure cycling, swimming, bicycling, and everything. And so this class is used to calculate the calories that are burnt by doing that exercise, by the time spent on the exercise and the type of the exercise. We obviously use scientific methods to do calculations, and so it basically just returns the get calories burned. This is the useful method because we're just basically wanting to return the number of calories burned because we were using them to calculate the net caloric intake in one of the scenes. This class is not associated with any other classes. It has no relationships. Our last class is the food options class. Now, when we ask the user what type of diet they prefer, we only want the foods associated with that diet type to appear in the choice box. So for example, if the user says they prefer regular diet type, then the choice box on the next scene where we ask the user to pick their breakfast, lunch, and dinner, we only want regular foods to show up. We don't want vegan or vegetarian foods to show up. So this food options class, this is basically used to put the appropriate breakfast, lunch, and dinner inside of the choice box that contains all these options. This is the only purpose of the food options class, to set the values of the choice box, which is apparent in our code. So this wraps up the UML diagram. Now I'm going to move on to the interesting and the challenging part of our code. So the most interesting part of our code was basically using hash maps. So we were trying to improve the object-oriented design of our program because at first we came up with a really procedural approach. And then we were trying to make it more object-oriented. And to do so, we needed better organization of code in classes. We needed to separate the code in different classes and have appropriate classes. For example, the abstract classes that we've used and the child classes. So to do that, we needed to find an easier way to organize our code. Because we were supposed to be storing food data, and each food item had to be associated with its own calories and its nutrients that it contains. And an initial approach was to use hard code all the if statements, which was not a good approach. And so we did some research and we came up with hash maps. And so we used hash maps to accomplish this task. Now, hash maps are similar to Python dictionaries, which basically helped us understand the concept. Now, if you look at the code snippet of the food data class, we have three different hash maps for regular, vegan, and vegetarian. And for the hash map of the regular, basically we store regular foods in there. We're basically storing the food, which as a string, the name of the food, and then we're also storing the nutrients alongside it, that using the nutrient class. So these are the calories, this is the protein, this is the carbs, and this is the fats. So basically what we're doing in the hash map is we're storing key value pairs. If you look at them in the reference of Python dictionaries. So we're basically associating this food item with its own nutrients. And this basically saved us from hard coding a lot of the if statements, which we would have done if we didn't use hash maps. So this was really interesting because this is something that was not taught in the course. This was like outside the scope of the course. And so we learned this by ourselves from YouTube and elsewhere. Uh, so this was something new, and using something that is not taught in the course gives you a feeling of accomplishment, which is really like, which is wonderful. And this initialization method is called in the main class. So when the application starts up, all these food items are input in these hash maps. So we feel like this was the most interesting part because this was something that was uh, done by completely by ourselves, learned by ourselves, and implemented by ourselves.
So we faced quite a few challenges during our project, but the biggest challenge that we all agreed that we had to overcome in terms of technicality was just the ability to change the scene for our application while linking it to the FXML controller class. Um, it was an issue at first because we weren't able to change the scene and have it linked to the controller, as in we couldn't have multiple scenes on one controller. But then we did our research on this specific topic and we were able to figure out how to change the scene with the linked FXML controller class. But then, due to this, we soon realized that one controller was not capable of validating input as well as processing and output for multiple scenes, as it just resulted in our code bugging out. Eventually, this led us to realize that each scene needs its own controller class to not only allow for the program to run effectively, but also so that our code would be better organized. Another challenge that we faced as a team was initially just being able to communicate frequently on the updates of our project, as we all just had overlapping schedules. But we were able to overcome this through frequent communications, through specifically messaging, and by informing the team members on the progress of our project and whether we were dealing with any ongoing problems regarding the project. And this basically allowed us to solve problems quickly as each team member was engaged in the project. So overall, we were able to learn a lot from this experience, both technically and as a team.